How many people are signed in? 4. Oh, 4?
Okay.
So where's the camera? Can they see me too?
They can if you stand here.
Yeah.
And then they will see what you're showing them on the screen.
Oh, okay.
Hello, this is Menno Ligterink.
Yes.
From
Very good.
Mastervolt. And with the chat with us, I graciously give this time up for us to introduce some of his products and situations. We met Menno at an ADYC function, and I would suggest joining with this big next ADYC will make you all the ADYC members, I'm sure, to attend their next in-house function. With that, Menno.
Thank you. The only problem, I got a technical difficulty here. How do I go to the next page?
Okay, where's our technical?
Where's our technical?
There it is.
It doesn't go to the next page.
I had that problem earlier.
Oh.
One didn't have that problem, did you?
It worked earlier.
If in doubt.
Oh, there you go.
There you go.
Yeah, that's the next one. All right. Does it work now?
Yeah.
There you go. All right. Good morning, guys. So my name is Menno Ligterink. I was born in the Netherlands. I came to the States in 2001 for Mastervolt to set up the distribution and sales here. In the meantime, my company has been sold 3 times already, so I'm now part of this big power products empire. And we own 6 major brands. So it's Anchor Wire, BEP, DC distribution products, and also C-Zone digital switching. Blue Sea, probably most of you come across this, been in the US for a long time. DC distribution products, switch panels. Marinco shore power, established in 1972. We do 30 amps, 50 amps, 100 amps, and 3-phase. Mastervolt, and then Pro Mariner. So that's kind of the family. Our recent acquisition was actually Lenco. It's not in this presentation. Renco Trim Tabs is based in Stuart, Florida, and that became part of this marine group now as well. So we have 3 major locations in the US, actually in the world. So we have Menominee Falls for the Americas. We have an office in Amsterdam for the EMEA. And then we have a little office in Auckland, New Zealand for the entire APAC region. And that's where also BEP came from. In case you guys have questions, you don't have to write this down. Go to our website. Every brand has a support line where we have technical service, customer support, and application engineering available. So if you guys have any questions, feel free to contact us, give us a call, or just shoot an email to us. So what I want to talk today is about battery chargers and the technology behind it. The battery technologies that we see today, including lithium ion. I want to go over some of the power and load management systems that you guys come across in the field, and some of the system integrations that we do with some of the electronic partners. It's a relatively small group, so if you guys have questions about a topic, don't wait till the end, but just interrupt me, raise your hand, and ask me a question, okay? So when it comes to battery chargers, we kind of broke up the business into what we call vented chargers and waterproof chargers. So the big difference is with waterproof, obviously it's waterproof, completely sealed. Some models are potted. The outputs are completely isolated, allowing you to charge multiple batteries that are even in series. So you can do 12, 24, 36, or 48 volts. They're typically limited to a group 31 size battery. And why do you think that is? Output? What's the biggest challenge that we have with waterproof sealed battery chargers? Heat dissipation. Exactly, heat dissipation. And so we're very honest. If a customer says, I want to charge an AD battery with a waterproof charger, that ain't gonna work. You're gonna fry the charger ultimately. Yep. So that's kind of how we break it up. Typically it's completely sealed. You have fixed cables lengths to it. It's about 6 feet. And there's a standard AC 120 volt or 230 volt plug on it. So this is kind of the landscape. So we own now 5 brands of battery chargers, and we're like, holy smoke, how are we going to do that? And how are we going to handle that? Well, the big difference between the chargers is really first feature set, the application, and the speed that you want to charge your batteries with. So even though all these chargers have some sort of overlap, they really go to specific applications. So the Promar 1, for instance, is a potted small charger just as a maintainer, up to 13 amps. Not really a charger to do deep cycle charging. It's purely for the winter to maintain the battery bank. The Charge Pro, for instance, can do universal input. So if you have customers that go to the Caribbean or they go overseas and they want to do 120 and 230, that will be a great fit. Pro Sport is a charger that has a pretty broad range. It's single phase 120 only, and it's really value for money. Pro Tournament really comes down to the speed and how quick you want to recover your batteries. So the Pro Tournament is available up to 3 outputs with 36 amp of charge capacity. That's really for the hardcore fisherman that goes out, comes back in at night, and wants to recover his batteries within 4 to 6 hours. The Battery Link is a new charger that we just brought out from Blue Sea last year, and I'm going to talk about that a little later. Now, all our chargers have distributed on-demand technology, and I'll explain to you what that is. So in the past, we used to have a charger that was 10 amps with 2 outputs. Okay, that means that one output could do 5, and the other one could do 5. But your total capacity was 10. The problem is that if you want to charge faster, you may want to do more than 5, and that one output is sitting at 1 amp, and the other one is sitting at 5 amp. Now, with distributed on-demand, you got, for instance, a 20 amp charger. Your total amperage is 20 amp. So the battery that needs the most juice will get the most current. So in this case, you're having a house battery bank here with 2 starting batteries. The house battery makes most of the time the most cycles because the start battery is always charged pretty much, either by an alternator or by the charger. And then what you can see here is that now 16 amps go to the house. You can see 2 go to start to the 2 starting batteries. So that's what we call distributed on-demand. So it gives you a faster, quicker charge and a quicker recovery of the batteries. That technology is now across all our battery chargers. And then we have the vented chargers. It's kind of a similar scenario. We have these different brands in line. You have the power charger, which is a 20 and a 40 amp. It's kind of an entry-level vented charger for the average cruiser up to 32 feet. We have the P12 that's developed by Blue Sea, and I'll talk about that a little bit later. That's kind of focused more on the emergency vehicle side of the business. Because it also controls an automatic charging relay. The Pronautic P is kind of a mainstream battery charger, anything from 15 amp to 60 amp and 12 and 24 volt. And if you have a network that you want to work with and connecting to an NMEA network, the Mastervolt Charge Master allows you anything from 25 amps to a 24 volt 100 amps. So that's all high power applications. Now, one of the things I always try to explain is what is the big difference with what we do on our larger chargers in terms of outputs? Most of our chargers have 2 or 3 outputs, and they're basically distributed on-demand, so they're commonly used in terms of a output with a diode. And so if you have 2 applications here with 3 battery banks, one is a center console and one is a big yacht, you can see that the difference is that typically on the smaller boats, the battery banks are equally sized. So it could be a group 31 or a 27. Those 3 are equally sized. Now, if you start charging that, that's fine, because currently, the current will be divided over those 3 outputs, and depending on whatever takes more will take more current. Now, if you get into a larger application like this trawler, for instance, you may have a much larger house bank compared to what the starting batteries are. The challenge with that is that if that house battery bank adds the most juice, and then it's going to charge for 10, 12 hours, those 2 starting batteries will ultimately be overcharged. Now, because it will follow that same charge algorithm. So what we do is on the larger chargers, anything over 60 amps, we're putting 1 main output in, which will charge in that house battery, and then we'll have 2 auxiliary outputs for the 2 starting banks. And the limitation here is 10 amp each. Does it make sense? Yep. Now, other technologies that we see in the market is charging multiple batteries to either a battery isolator or an automatic charging relay. So a battery isolator, and in this case it's based on an alternator, is basically 2 diodes, and those 2 batteries will never see each other. So the current will be divided up, it will charge the most empty battery first, and then it will go over to the next one, and it will top both batteries up at the same time. Who's familiar with an ACR? Yeah, so what that does is basically a relay, a voltage sensitive relay, or an automatic charging relay, that senses this battery bank side, As soon as it sees the voltage increase over 13.7 volts, it closes that contactor, allowing that second battery to come online and charge at the same time. Yeah? So you basically start the engine while the two batteries are completely separated. As soon as there's a charge current available, the two batteries are tied together. Yeah. Now this is a new charger that Blue Sea brought out. Actually, it's already 2 years ago. It's a 10 amp charger, and instead of having to install a separate charger and a separate ACR, automatic charging relay, they combine the two into one. So you'll see these coming out now, primarily center console, smaller boats where you have 2 or 3 battery banks, where an alternator needs to charge both batteries. So when you plug into shore power, the 2 batteries will stay completely separated. It will recharge batteries individually, and then when the alternator runs on the outboard engine, the ACR basically combines the 2 battery banks and makes it a single bank, and will charge both batteries at the same time. So nice.
Excuse me, how's that working with a small generator with a battery charger? Those two of them, the opposing alternator kind of charge.
From a little generator?
Yeah.
It will be exactly the same. So as soon as that, so it's dual sensing. So it's sensing on both sides of the battery banks. So if that engine of that alternator is connected to this bank and it senses that voltage, it automatically closes that contact and recharges other batteries.
But if the generator is running the battery charger, the alternator is hooked in, because a lot of the older chargers, you have to make sure that the battery charger is turned off when you're running the engines because you're making.
So your point is that if the generator is connected to this battery, and that generator is running and supplies AC power to this,
Yes.
then basically the battery charger will keep that contactor open.
What about when the generator is trying to charge the battery?
The alternator, it doesn't matter. As soon as the battery charger gets AC power on the input side, it will leave that contactor open. Okay? Good question though.
So it will not take the power from the alternator.
Right. Well, it will take the power from the alternator, but only for that particular battery. Which actually helps, because what happens now is that current will then, on the charger, will primarily go to the second battery. So you will get a faster charge. Good question. So another way of avoiding overcharging smaller batteries is this new battery charger from Blue Sea. And this is a technology that we're going to actually roll out into all our chargers moving forward. And that's what we call a pre-float, which is, this is basically a 4-stage battery charger, where the 4th stage basically looks at each output individually. So in this case, you have output number 1, which could be your house bank, and then your 2 other outputs will be connected to your 2 starting banks. What it does, it senses those 2 second outputs, and if that current starts to drop at some point, it goes what we call into a pre-float stage. What that does, it basically drops in the voltage from 14 volts to 13.5 for those 2 starting batteries, allowing the maximum output on battery bank number 1 to be its maximum current. So that would then finish off the house battery. 3-stage charge algorithm. So you guys familiar with that? To a certain degree? Mike, you probably do. All right, I'll walk you through it. So if you see basically there are 3 stages to charge a battery. If you see battery charger manufacturer that advertises 5, 6, 7, 8, 9, 10 different stages, that's all marketing. Okay, you really need 3 stages. So they're called bulk, absorption, and float. Float is basically a maintenance charge at the end of the whole cycle, and it will keep then the battery topped off while it's supplying current for any load that's connected to it on the boat. Okay? In the first stage, what you're looking at here, the red line is the voltage, and the blue line is the charging current. So in the first stage, you're actually putting the most amp hours back into your batteries, because you're going to your maximum current at that point, while the battery voltage starts to climb. Okay? You get to the top here where you basically hit what we call the gas voltage, which is 14.25 volts. And actually, we have a little bit of bump in here, but I'll come to that later. At that point, you will stay in that bump here for 15 minutes. At that point, the charger will go to absorption, and it's charged almost up to 75% at that point. At that point, it holds the voltage steady at 14.25, and it lets the battery decide how much current it's going to take. Okay? Now, I get customers that want to charge their batteries faster. And so they take an AP battery and they want to take 500 amps of charge capacity on. As you can see here, at this point, you can put your 500 amps in your batteries. When you get to your second stage, for your last 25%, that battery voltage stays basically steady, where the battery decides how much current it's going to take. So you only have so much power that you can push back into a battery. There's always a ratio. We typically take 20 to 30%. Now with lithium technology, that's different, but I'll come to that later. So at this point, it will basically start, the battery start filling up to 100%, the current starts to drop when you get down to about 6% of its maximum output. So if you have a 100 amp charger, it will be about 6 amps. At that point, it says, you know what, the battery is full in my opinion, I'm going to float. Yeah? You float, it basically maintains the voltage at 13.25, and any current that's required for any loads that are connected to it will come out of the battery charger and not out of the batteries. Yeah? Now, there are some limitations here because you say 6%, but what happens if there's loads connected to it and it will never reach that 6%? Well, therefore, we have timers built into it, and it's hard to see here, but every modern switching technology battery charger that has a microprocessor in it has timers in it. Now, that's very tricky because if you get to this point where it says 13.8, one of those timers kicks in, what we call an absorption timer, and from that point on to this point, you only have eight hours to finish your charge cycle. If it doesn't finish the charge cycle in those 8 hours, it automatically pushes itself into float. Now, what does that tell you? That means that customers that use a huge battery bank, let's say 2,000 amp hours, and are putting a 50 amp charger on it, that charger will never get that battery bank topped up, even though it's sitting there for 20 hours or 30 hours. And the reason is that those timers kick in. So even though that charger goes to float, let's say after 12 hours, that battery is still not full. You guys following that? So there's always, and that's that educational part that I always have with OEMs, it's like don't undersize your chargers because at the end of the day, you think the battery's full, but it's not full. Yeah, ultimately the timers will kick in and will push that charger into flow. Yeah. Now another nice feature that we have in most of our chargers is what we call a plus stage. So if that boat sits in storage for the winter, for instance, it's good to wake up that battery every once in a while. So every 12 days, automatically the charger pushes the charger back into a new cycle. That means it wakes up the battery bank, the voltage will come back up again, and it goes to its cycle probably in 45 minutes or so. Don't feel it. Yes, sir.
Question, the exact opposite. Let's say that it is properly sized. It brings the battery up to 12.6. The battery's fully charged. Are you then maintaining 13.2 output on the charger, or does it ever actually shut off?
Nope, it never shuts up.
So you do still run the possibility that you could be gassing out the battery just a little bit?
No. No, 13.2, the nominal voltage of, let's say, a lead acid or an AGM battery is around 12.8, 13 volts.
Yeah.
So you're just above that. So there's a very minimum current flowing through that. You're looking at milliamps. It's compensating for the self-discharge of the battery. And actually, especially in the wintertime, that's really good. Because if the battery just sits, ultimately, and it freezes, it will freeze up the battery. If you keep a very minimum milliamp current flowing through it, I mean, my boat is here plugged in now as well. It will prevent that then from freezing up.
So at a constant 13.2 into the battery,
no problem.
Will not cause any
Nope.
outgassing.
No, not at all. Yes, sir.
Where does your 4-stage pre-float fit in there?
Well, this is talking the 4-stage free float is currently only in that Blue Sea charger that you saw earlier, that P12. These are the Mastervolt charge algorithms, but that's kind of changed. We're actually developing a new line of chargers, and that pre-float will be part of that new process and the charge algorithm. So back to this. So what we do here is we have an automatic voltage drop compensation. And when is that important? When is that important? When a boat, for instance, is out there and it's out for anchoring, runs off of its generator. And in order to reduce generator running time, you want to push as many amp hours back into the battery bank in that first stage. So with that little hump that you see there, we're actually compensating for the cable losses between the battery charger and the battery bank. And this will actually gives you, it's only a 0.15 volts. So we took an average installation where the battery charger is about 6 to 8 feet away from the battery bank. That voltage drop is at that maximum point about 0.15 volts. So we're pushing that extra voltage in. The battery will only see 1425. The cable losses will basically eat that 0.2 or 0.15 volts, and that will give you some extra amp hours back into the battery bank. Now, temperature compensation. This is always a great discussion. Every charger that we sell will have a temperature sensor. And the reason that we do that is that, look at this graph, for instance. First of all, I don't know if you guys noticed, but this is a fact. Every 5 degrees C over 25 degrees C will cut your lifespan on your battery in half. Yeah, so if your battery sits full time at 30 degrees, and it would normally last 5 to 6 years, you're lucky if you get 3 years out of it. Okay, so that's one thing. So in order to help that battery to extend its life, we put temperature sensors on. So what you see here, this is voltage, this is temperature. All the chargers are typically laid out at 25 degrees C. That's kind of an industry standard. That's that blue line that you see here. So this is your absorption voltage, and this is your float voltage. So the absorption voltage is typically 1425, that we just talked about earlier, and your float voltage is about 1325. Now take an example. It's not uncommon in Florida that in the summertime it's 100 degrees in the engine room, right? So look at 100-degree Fahrenheit, what that absorption voltage is. So this is the absorption voltage. You're looking at 13.8 pretty much. If you would not have that temperature sensor plugged in, you would have been at 1425. That means you're overcharging the battery more than half the volt. Yeah. That's why it's so important to have that temperature sensor connected. Another thing is that temperature sensor also cuts off the charging voltage when you're exceeding 55 degrees C or when you get under -20. Very tricky for batteries to charge them outside those two parameters. Yeah? Does it make sense? Yes, sir.
The voltage sensors, I constantly see the little sticky back units.
Yes.
And I constantly see them knocked off. Do they still function if they're not adhered to the battery but just sitting on it?
Ideally, we put them between batteries. And so because then that's the hottest spot.
Right.
But technically, it's measuring also the ambient temperature.
Yeah,
so even though
I see the people stick them right on the top of the battery, but then somebody goes in there and while they're working, they step on it and the darn thing gets knocked off.
It's not ideal because you're no longer sensing the battery itself.
Right.
Because at some point, ambient is one, but while you're charging and discharging, your battery starts to heat up too. So when you're recharging it and the battery is hot, I mean, that sensor will detect it. If it's not, you're only going to measure then the ambient temperature. But it still functions, but it only will measure ambient temperature. Yes?
You don't want it on the top of the battery, do you? Because of the airspace, and you want it on the side.
I want it on the side. And preferably between batteries if you have multiple batteries side by side. Yeah? I've got another feature that we built in, even though those chargers are all universal input, so they can do anything from 90 volts to 265. We said, you know what? What happens? You're either in a split phase configuration at 240 volts, yeah? Or in a single phase 120 configuration, which is right here. If you have a voltage coming into your charger in this spectrum between 130 and 170, you've got a serious problem with your short power or with your generator. So at that point, that charger will automatically shut itself off. Yep. I got a lot of questions about, so how do I size a battery charger to a bank? So I've got a couple of rule of thumbs that I wrote down. We typically take, for house bank applications, 20 to 30% of its battery capacity as its charge capacity. And that's just a rule of thumb. I must say that now with LED technology, it's leaning more towards 20% than to 30%. Back in the day, it was more 30%. So if you have a 200 amp hour bank, 20 to 30% is anywhere from a 40 to a 60 inch charger. And that includes the recovery of the battery, but also the average loads that are on the boat, that are continuously running. Obviously, when you have a 100 amp charger, you run 20 amps on loads on the boat, there's only 80 amps going back into that. Yeah. For thrusters and starting batteries, we don't need to go that high. 10–15% on average is fine. I mean, there's no load connected to it. You typically are plugged in or run the generator. The batteries are full, and it will recover that way. Another thing is I still see a lot of boats, Mike can probably confirm that, coming in from Asia, where we have one charger charging 5 different battery banks. It's not going to work. That battery charger, even though it's distributed on demand, can only focus on the most demanding battery with the lowest internal resistance. If you run all these batteries from one single charger, that's asking for 12. So only max that out to 3 outputs, 3 different banks, and that's it. If there's a substantial size difference between the banks, use the chargers with the big output and the 2 auxiliary outputs, or use 2 separate battery chargers. One for house and then one for the starting batteries. Another option moving forward would be using chargers with the pre-float application. Bow thrusters and winches, I see it all the time. They're tying them into the house battery charger. The house battery charger typically sits away pretty far from that winch or thruster bank. Always use a separate dedicated charger for that. Don't tie it into one of the outputs of the main bank. Any questions about chargers? All right.
Do they make dual voltage output?
Say that again?
Do they make a dual voltage output charger?
Yes, but only on the waterproof side. So if you take a 12-volt waterproof charger that has 2 outputs, you basically have 12 and 12. So that could charge a 24-volt bank. If you have a charger with 3 outputs, you could charge a 36-volt bank. The Pro Elite series actually has 4 outputs, so you can do a 48-volt bank. Does that make sense? Say it again?
So are you putting power on 4 12s, and you putting all 4 outputs on one?
No. There's 4 leads coming out with a positive and a negative. So you put them over each battery individually. So it will charge actually every battery
So
individually.
you're not going to backfeed
Nope. Nope.
the connectivity of the series on the.
No. These waterproof chargers all have isolated outputs. So if you have one with 4 outputs and you have a 24-volt bank, you could actually double up the leads too. Gives you double current then per output. Yeah. All right, let's talk about networking real quick. Masterbus is a high-speed CAN bus-based network. It has a proprietary overlay. Basically what it does, it's based on a Cat5 cable, where you daisy chain all your different components in, and it allows you to control and monitor everything from a single control panel. Yeah? You see this a little bit more and more coming in. This is an example of what we do. This is a master shunt and a DC distribution box. So in the past, with a battery monitor, we used to have a microprocessor with a display. We used to have an analog shunt. The shunt information from the in and outgoing current from the battery bank goes to the display that calculates the state of charge, and it gives you an indication of how full or how empty your battery bank is. This digital master shunt basically does that for you down in the engine room. That shunt has all the technology in it, and that information is then injected into the network, and that network can actually then be used for several applications. So first of all, you can see then your state of charge off of the remote, but it could also talk to a little contactor interface or start a generator when your battery gets to a certain percentage state of charge. Okay. This is a DC distribution box, just another example. Those two really nice come together. They have standard A&L fuses in it, but the network is actually monitoring those fuses. You can electronically label them then in the system. So you could call one main DC distribution panel, you can call one alternator, you can call one battery charger. So if any of those fuses pop, it actually would come up then on the display saying, hey, your inverter charger fuse just popped in the engine room. So the customer now knows what the actual issue is. Yes, sir?
Does the master shunt have overcurrent protection?
Yes. So in the master shunt itself, there's a T-class 500 amp fuse. And that's actually a circuit protection. So if you want to comply with ABYC and you want to stay within the 7-inch range or 42-inch range, you can actually use that shunt close enough to the battery so you don't have to have a separate inline fuse. for the system. These shunts are 500 amp each, but you can actually parallel up to 4, and then electronically in the network, you can combine the two. So you will see one state of charge, 1 voltage, 1 amps, and 1 time remaining. Well, I'm not going to go through all this, but we have a whole series of interfaces. We speak NMEA 2000 also, so there's a gateway that brings that information from the master bus network, let's say state of charge, to a NEMA network, and then you can see on your Garmin or on your Ray Marine what the state of charge is of your battery. So this is kind of how it works. So we got a battery bank with a charger, basic remote control. The customer now can control the battery charger. It will see its output, but it doesn't see state of charge of the battery bank. So it's kind of a building block. You're putting your shunt in. It now measures the in and outgoing currents. So now you got a little system going. Now the customer decides to install a bow thruster with a battery charger. It charges that battery bank. The fun thing with this is that even though there's no AC on the boat present, no generator, no shore power, the charger will continue to monitor the voltage on that battery. And that information actually comes back into the bus. It is a sensing device then for the remote panel. So even though the boat is offshore, the customer can still see what the voltage is of his thruster bank. This is another example. I mean, you can expand the system and make it just as big as you want. All right, any questions about networks? No? All right, let's move on. Batteries. All right, so we have 6 major battery lines. I'm gonna run you through some of the different technologies that we have. So it's basically the core of the system, of the electrical system. It's an evolving technology. I mean, we started off with flooded batteries years ago with a little single light bulb. Over time, you know, AGM came across, and also gel. What you see these days is tin plate technology, and then the latest and the greatest is lithium ion. Average lifespan that you see on these batteries, with the exception of lithium ion, is anywhere between 4 and 6 years. So we're looking actually at 3 different types of batteries. We have start batteries, semi-traction, and traction. So start batteries is basically a thin plate technology, has a lot of surface, and actually supplies a lot of current in a very short period of time. Okay? They're not really good in making cycles, and I still see builders putting those batteries in for house and thruster applications, and that's not what they're designed for. Traction batteries is the completely opposite. It's a thick plate technology with more surface. It's really designed to supply a lot of current over a longer period of time, and is really designed to make deep cycles. Now, kind of the in-between is what you see of most of the time that you see in the market for house applications, what we call semi-traction. It's actually in between a start battery and a full traction battery. We typically don't discharge in more than 50%, and they typically last anywhere between 400 and 600 cycles. Yes?
How can you tell the difference by looking at it? Which is which? It's not
The
indicated on them.
No, well, the start batteries are typically indicated on them because you'll see a CCA rating.
They all have CCC.
Yeah, they all CCA rating. If you look at a house battery, it's also gives you reserve capacity,
Right.
and sometimes cycle life.
So basically, your cycle life will tell you whether it's a fixed
Yes.
plate or, you know.
Right.
Okay.
What about weight?
What about weight?
Weight.
Yeah, weight is a factor there too. I mean, the starting batteries are typically lighter. Yeah. But any AGM battery, for instance, is a combination start and house. So that is kind of a semi-traction battery. All right, talking about batteries. I mean, this sounds silly, but I still see a lot of people calling us with questions about their battery banks. So typically, if you want to double your capacity, you're paralleling your battery banks, right? So you hook up the negative with the negative, and the positive is positive. So these are two 200 amp hour batteries. So that makes it a total of 12 volt, 400 amp hours. When it comes to 24 volt, you have to put the batteries in series in order to double the voltage, but it does not double your capacity. So it's 24 volt, 200 amp hours. That's where people get confused. They call and says, no, I got 24 volt, I got 400 amp hours. No, you don't. You got 24 volt, 200 amp hours. All right, so cross wiring. What is wrong with this picture? That's funny.
You're drawing the load off Just one battery.
That's right. That's right. And it's interesting because this is one of the main issues that we see in the field, why batteries prematurely fail. Is they're putting a load on the first battery, and even though these cables are very short, they still create resistance. So every time when you make a cycle, you charge or discharge, this battery works less hard than that battery. This battery most likely will premature within half of its life. Yeah. So that's why we say you need to cross-wire your battery bank. Oh. So you take always the negative off of one side of the bank and the positive off of the other side. Now this current has to flow this way and this way. So now they perfectly load balance between the two batteries. That make sense? Do you guys see this a lot? No? All right, let's talk about AGM. So AGM is actually what we call absorbed glass mat. So when you have a standard battery, I don't want to go too deep into it. It basically it's a lead plate that sits in acid and water. With AGM, with absorbed glass mat, we're putting that acid and water in a glass mat construction and actually stick it to the plate. And that makes that what we consider a dry battery. It sticks to it. It's very vibrant resistant. You can very quickly recharge them. They do require some special charging algorithms, so make sure that you select a proper charge algorithm on the battery charger. Average is about 250 cycles. Do you guys know what a cycle is? Okay, cycle is basically when you have 100% charged battery down to 0, back to 100%. That's what we consider one cycle. Now, from a life perspective, we basically say don't discharge your battery with more than 50%. So that means if you go down from 100 to 50, back up to 100, that's what we call then half a cycle. If you do that twice, then that's one cycle. So on average, it's 250 cycles for an AGM battery, but in reality, customers are discharging it only 50%, so they're getting actually 500 cycles out of it. Right? Yes?
A number of boats with fairly large AGM battery systems on, especially with inverter systems, where the boats will sit in the wintertime and either they forgot to plug them in or they're in storage, and the AGMs will discharge, and you cannot get them above like 11.85. Is that just the batteries will ruin?
That's sulfation. So if the battery sits anywhere below 10 volts for a longer period of time, the plates are kind of starting to corrode. Now, there's a couple of ways to do that. In our chargers, there's an option to equalize. What you need to do is you turn off all your loads, and it actually brings the voltage up to 15.5 volt per battery. That will break some of that sulfation off of the plate, but it is kind of a band-aid. It's not that you're bringing back the full capacity of the battery.
But this can happen with AGM batteries. Right?
That can happen with gel, AGMs, or wet cells.
But I'm talking about the lifespan of batteries. Some of these batteries are going through one winter, and that's all it takes.
If they leave them dead, any type of, you can completely discharge your batteries until it's dead, but as long as you put it back up within, let's say, a day, you're probably fine. If it sits down for a longer period of time, let's say 2 weeks plus, then you get sulfation on the plates, and then your batteries are basically damaged and ruined. This is a battery I wanted to point out real quick. It's an AGM compressed technology, and you'll see those batteries. Mastervolt makes one, but there's also one from Northstar. There's a few other brands. Odyssey has one too. You see this in the field because it originally came from the telecom industry. It's a rack mount battery. They're very narrow and taller than an average, let's say 40 or 80 battery. But the cool factor is that they actually fit two side by side in the footprint of a standard AD. Now an AD is about 225 or 250 amp hours. So if an existing boat needs more capacity, they don't have the floor space, they like to go with this style battery because two of those 200s will give you then together 400 amp hours over 255. Yes, sir?
Can you mount a AGM or a sealed battery on its side?
That depends on the construction. This battery, yes. And always put them then on the longer end because the plates are in there like this, so that the short plates are actually standing up like that. If you put them up like this, the plates will start to bend, and ultimately the battery will prematurely fail. Yeah? Gel batteries, well, gel batteries are more deep cycle battery. Any battery manufacturer you talk to, they would recommend gel over AGM for house applications. You can deeper discharge them. They can be left to discharge, you know, they're a little bit more forgiving when it comes to abuse. Vibration resistant, you get about 400 cycles out of it, but it will require a slower recharge. I mean, the percentage is lower than what you typically do on an AGM or a lead cell. Then we see thin plate pure lead technology. So basically that's pure lead plates that are sitting in, instead of using a lead alloy. The only downside to that is you need a much higher charging voltage. You see some of them that actually require up to 15.2 or 15.5, which is pretty high. And your nominal voltage is higher too. So they're typically sitting at 13.2 or 13.5 instead of 12.8. But it's something that we see more and more. It's being used for cranking as well as deep cycle. Lithium ion. Who has come across lithium ion?
Samsung.
Yeah? You see them?
No, I'm just talking about Samsung with the phones.
That's true. That doesn't help me sell more batteries, by the way. Same as that Dreamliner issue that we had. So, I mean, we're using lithium ion as a standard name, but actually there's 12 different, well, more than 12 different chemistries within the lithium ion family. So as you can see here on the top, there's polymer, there is cobalt, magnesium, and lithium iron phosphate is kind of the most commonly used one in the marine industry and mobile industry. The reason for that, it does not have the highest power density, but it's the most stable version of it. The last thing that we want to have is a fire or an overheating situation in the bilge of a boat, and we're burning down a multi-million-dollar boat. So most of the marine lithium-ion batteries you see is based on iron phosphate technology. It's a flat plate technology. It can handle G-forces. I mean, boats are slamming into waves, so we have to have that. The Mastervolt battery has an active BMS system, and I go into that a little bit later. And that's part of the whole concept that we have. So this is kind of what we're looking at. The lifespan is significant. You saw that earlier where you have your AGM batteries up to 400, 250 cycles. These batteries last over 2,000 cycles, and it's actually very conservative. We typically allow deep discharges up to 80%, so with a 20% remaining, and I'll show you why in a few minutes. There's no time constraint on those batteries, and here's a tricky one. The thing is with lithium ion, what you've learned in the last 20 years about battery technology, you can completely erase that and start over because this works completely different. So the no time constraint means if you have, let's say, a 200 amp hour battery that's rated at what we call C20, you must have seen it in specs, right? Or C10 or C5. C20 is kind of the industry standard. So that means the 200 amp hour battery can supply 20 hours, 10 amps. That's what the C20 stands for. Okay, so 10 times 20 is 200 amp hours. It doesn't mean that if you have a 20 amp discharge that you get 10 hours out of it, because that's not a linear curve. You're probably going to get 6 to 8 hours out of it. With lithium technology, it doesn't matter if you discharge it in an hour, 5 hours, 20 hours, or 100 hours. You always have that same capacity always available. So when does that come in place and be interested for users is when you have heavy loads, aquaculture, inverter systems, high power backup systems. That's where you basically have more power compared to a conventional battery. Yeah. So if someone asks me like, so I got this AD battery, what does that compare it with this? I technically cannot compare it unless we know what the load is that's on the battery. If that load is similar to a 20-hour discharge, then it will be comparable with a lead acid battery. Yeah? Are you following me? All right, so, well, it's very, I mean, we can really charge them quickly. We do up to 2.5 C. That means that a single battery can be charged up to 500 amps. And our limitation is really basically the bus bars that are built into the battery. So that means that we can recharge a battery in less than 45 minutes, which is really fast. Temperature range is kind of the same thing. And every battery needs a BMS system. Now there's I'm not going to go over these specs, but there's a 12-volt version and there's a 24-volt version. And so there's a single battery. You don't have to put two in series in order to have a 24-volt unit. So what is the BMS? It stands for Battery Management System. Now the issue with lithium cells is that if you charge them, and they're all sitting in series, one battery could take more capacity than other batteries. Now lead acid batteries do the same thing, but that will automatically balance out as you're charging and discharging them. With lithium batteries, you don't have that behavior. One cell could end up at, let's say, 100%, where the other one is 95. The next time when you recharge and charge it, it will do the same thing. Now the BMS system, what that does, it balances the power between the cells. So it's kind of a DC-DC converter. So excessive power from one cell, so one cell starts filling up quicker than the other one, it brings that power then over to the other cell. And I actually have a little bit of an animation here that shows that. So this is a battery where you're taking out 100 amps, yeah? So each cell provides 100 amps, but you can see that this cell was more charged, so this will do more current at this point. And that's controlled by that BMS system, yeah? Same as when you recharge the battery. So you're putting 50 amp in, but you see that this battery cell takes 60 amps, where this cell only takes 46 amps. This whole process works while you're charging and discharging, but even when you're done, at the end of it, and there's no current going in or out, that whole system stays active until all the cells are equally recharged. And this is the key to the success of a lithium battery bank, because if people don't use BMS, you're not taking and not getting the full capacity out of your battery bank. Yeah? Now here's another graph I wanted to show you real quick. This is basically battery capacity. And you can see this as a scale from 0 to 100%. And this is your battery voltage. Now here you see the big difference between lithium, discharging, and conventional AGM or lead acid battery technology. So you can see while you're discharging, the voltage stays very high, and at the last 20%, it drops down significantly. This is something you must recognize from your cell phone, because your last 15% goes much quicker than your first 15%. And this is the reason why we don't allow to deeper discharge than 80%, because if you get into this point, the boat is basically dead suddenly. With standard AGM batteries, you see that this is a much gradual kind of discharge, and your voltage slowly starts to die. That's where you see your lights kind of starts to dim. With lithium, all of a sudden, you're in a dead ship. Yes?
If you don't use a battery management system where it's going to be battery, do you damage them?
Yes, ultimately you will. Now, the thing is, yes and no. If you charge them the way we normally charge batteries in the marine market, yes. If you really slowly charge them, you probably won't have much of a problem. And where do you see that? For instance, in golf carts. Yeah, so they have lithium batteries in it, or forklifts. They charge them overnight, they got whatever, 12, 15 hours to recover them. With this technology, the advantage is that we can so quickly recharge them, where we run alternators offshore, or we have a generator running for a certain period of time, then that becomes a really serious concern. Yeah?
What about the fire hazard with lithium?
I'm going to get into that.
Do you have battery chargers that have the battery management system built in, or must it be a separate device?
Nope. Actually, in our battery, the BMS is built into the battery.
It's into the battery?
Yep.
Okay.
What you see here, this part, this is the BMS system. It sits in an IP65 enclosure. This is mounted on the battery. That's actually very unique, because most other lithium manufacturers had that as an external device, but we're building it into the battery. So even if you build a bank out of multiple batteries, each battery will have its own BMS system. Yeah? Now let's zoom in real quick on that graph that we saw earlier. So this is a discharge curve that you saw from the lithium battery. I get customers that are calling me like, I want to have an automatic start-stop system on my battery bank that if the voltage gets to a certain point, it restarts the battery, or that restarts the generator to recharge the battery. And I'm saying that you can't do that. Here's the reason why. So a nominal battery, like a lead acid battery, is 12.8 volts, right? Or 12.6 volts, somewhere in that range, all right? The lithium battery starts actually at 3.3 volts per cell, which comes down to about 13.25 volts. If you see here at 80% discharge on the graph, you're looking at a voltage of 12.6. So the difference between 100% charge and 20% state of charge is less than half a volt. No, a little bit more than half a volt. So doing it based on voltage doesn't make any sense because the voltage difference is minimum. You really have to get based on amp hours or kilowatt hours that you're taking out of the battery. So that's where the big difference is. Now back to your concern about the fire. So what we do is, this is a typical lithium system, and everybody uses a safety disconnect. So this is a safety disconnect. It's a latching relay that we use from Lucy Systems. It connects direct to the battery, and the battery basically monitors volts, temperature, current, over voltage, under voltage, any scenario. And if anything happens and it goes outside those parameters, it opens up that latching relay and it takes itself offline. Yeah? Now, if you have a single battery in a boat, that could be a problem because then you have a dead ship. But if you have multiple batteries, you put multiple latching relays in, one for each battery. And if there's an issue with one of the batteries, it will take itself offline. So in theory, technically, we would never come to that stage that you were just describing. Yeah? The other thing is lithium iron phosphate cannot basically ignite itself unless there's an external heat source. Yeah, so the fires that you see with lithium iron phosphate, probably a hot exhaust or another something that's hot must have ignited it.
What about extinguishing the fire if it doesn't ignite?
Well, the best thing with that would be is to completely submerge it in water or with foam. That's it.
So let the boat sink.
Basically let the boat sink. Yeah, there you go. All right, so this is kind of a quick comparison between an AGM bank and a lithium bank. Why do people want to have lithium? So what you're looking at is 4 AGM batteries. Total capacity is 450 amp hours at 24 volts. Yeah, and a single lithium ion 24 volts, 180 amp hours. Yeah. So what we did is we put a 70 amp load on this bank to see what the differences are. So the time constraint on the AGM battery bank with a 70 amp load, and this is information you can get out of the spec sheets from a battery manufacturer. Suddenly, because of the time constraint of an AGM battery, the capacity is no longer 450 at 70 amp, but it's 276. Yeah? We typically discharge those batteries at 50%, so really your usable capacity is 138. With lithium, we just learned there is no time constraint. We have 80% capacity available, is 144 amp hours. So you almost have the same capacity in this scenario. Compare 4 batteries to 1. Look at the weight difference. That's the reason why people use lithium. And from a cost perspective, yeah, the battery costs $350 retail right now. But if you look at the cost per cycle compared to AGM, actually lithium is already cheaper. It's just a long-term investment. If you decide to sell your boat in 5 years, you probably want to go with an AGM bank. If you want to keep it for a long period of time, that would be definitely worth investing. Another question about mixing chemistries. In general, that's not a good practice. The problem is that different chemistries have different charge algorithms. If you mix an AGM with a lead acid, you probably want to select then the lead acid, the AGM setting, because that's lower voltage than lead acid. But mixing a lithium battery, for instance, with an AGM, that's not going to work. You're going to overcharge the battery bank. So what we typically do is we take the alternator from the engine, we have that charge the lithium bank, and then we use a DC-DC converter to charge the starting bank from the lithium bank, just to maintain. All right, any more questions about batteries? How are we doing on time? Oh, I got 3 minutes left. Can I run over a little bit? Yeah? Yeah, John doesn't need 45 minutes, so.
Yeah.
Someone had a question? Yes.
You're calling a cycle going from 100% to 0, right?
I'm back to 100, yes.
Okay. Suppose you go from 150.
Yes.
Does that double your amount of cycles?
Yes. Yes. So the 250 cycles that you saw for AGM, in the real world, that's probably 500 because people don't discharge deeper than 50%. Yeah. So if you discharge 10% and you go back up to 100, you can do that 10 times before you have 1 cycle. Right? All right.
Battery memory, that's the things on.
Oh, that's back in the NICAD days, right? Yeah, no, that doesn't exist anymore. No, that's over. Matter of fact, some people think that you need to make a cycle on lead acid batteries so once in a while because it's better for the battery. It's not. Basically, basically shortens the lifespan. I do believe in what you saw earlier, where you do every 12 days and kind of waking up scenario, where you're kind of increasing the voltage and wake up that battery a little bit. Especially for gel and AGM, that's pretty important. All right, digital switching. That's scary, isn't it? Have you guys seen it in the market yet? You? Yeah, we're selling close to 100 systems a month right now, so you must run into it at some point. So what is digital switching? This is the formal statement: a system or signal involving simultaneous transmission of several messages along a single channel of communication. I have no clue what that means, but we'll get to that. So basically, a conventional system, you got a power supply, you got a fuse, you got a switch, you got a load. There's an overcurrent scenario. The fuse pops, and your circuit basically trips. Right? Digital switching, you have a current measurement device, you got a electronic or solid state contactor, what we call it, and we got a microprocessor monitoring all this and controlling it. So it detects a fault, it says that to the processor controls the MOSFET and opens it up. That's how it works. Now the cool thing about this is the microprocessor can be told at what current it needs to trip. So our devices are either limited to 10 amp or 20 amp max, but I can set that anything from 0 amp to 20 amps. So if I have an existing circuit and it's now set for 5 amps to trip, and I'm upgrading it with more lights, I can set it to 6 or 7 or 8 amps. That's the flexibility that customers get. Yeah. So this is kind of an idea. The backbone that we use is NMEA 2000, and that's also the big advantage with our integration partners. So basically, what you're doing is that output circuit with that MOSFET is controlling now the load. So your current is not carried by the switch anymore. The only thing the switch does, it tells an analog to digital converter, hey, I want to turn on now. From there, it goes to the NEMA network to the output device, and the output device then turns on. So this is a little simulator. You push the switch, that signal goes to the interface. The interface goes to NEMA, and then the current comes direct from the battery bank to this unit to the load. So this can be anywhere in the boat without having to carry the load. Yes, sir.
It seems like a nightmare to diagnose if there's a fault. Where before you might have a fuse or a circuit breaker, now you have a processor, a digital management, NEMA. I mean,
yeah, we have processes to troubleshoot that. It sounds complicated. No, it's not that complicated, and I'll show you in a second why there's redundancy here too. Okay. So first of all, you can always plug in a laptop and monitor the network and see if the actual contactor is giving that signal to here. That's number one. The number two I'll come into in a minute, okay? So now because it's basically a switch that controls through a digital converter, we can also have virtual switches now on touchscreens controlling a circuit. Yeah? The cool thing about that is that you can do one switch controlling multiple circuits. You can also have one switch turning everything off on a boat. So that is a lot of flexibility that's been offered. Now from an installation perspective, and this is where the name C-zone comes from, is we look at the system as multiple zones. So we have zone 1 through zone 5, where you have your battery bank with a main DC distribution, typically in your room, goes to your central breaker panel. 2 switches, 2 dashboard switches to your load. What we're doing with C-zone is we're skipping basically your standard breaker panel. And this is the way I explain it too, is we're bringing now your circuit breaker actually to your load. And so these boxes are typically spread out over the boat in different locations, what also helps the builder to use less wires. So this is a great example of how it would look like when you blow it up with a bigger system, where you have 2 control stations, where you always have to duplicate everything. So all the power from the battery goes to your DC distribution, to your switches, to your second switches, and then it goes to the load, right? From dual controls. In a digital switching world, we're simplifying it with just a NEMA cable. Because this switch is controlling the load to the interface, but this switch is doing it to the NEMA network too. We have builders that have controls up in the towers that they used to run, bundles of cables up to. All they're doing now is they're putting a Garmin screen at the top, NEMA cable down, that's it. You can control and monitor everything else off of the Garmin screen. Good. Another advantage here is, like I said earlier, you can do multiple outputs with a single touch. So in the conventional world, we just turn on all these switches, it turns on all the lights. If we go to the digital world, it's just a matter of pushing one button and it will turn all those circuits on. Yeah. There's a couple of features why people decide to go with digital switching. It's flexible, like I said earlier. It saves definitely on wiring. The remote control feature is really cool. So people will get like a remote control like you have in your car. So before they even step on the boat, they push on one button. The latching relays or the motorized battery switches will automatically close. So before the customer even steps on the boat, the system is already live. There's 4 buttons on it. We typically program it in a way that you have to hold the button in order to shut everything off, just like in your car or when you have to double push it. And then we have 2 extra buttons on it that could do, let's say, basic courtesy lights. So if a customer goes to a restaurant, he docks his boat, comes back in the dark, now he can turn on his courtesy lights before he even steps on the boat. Yeah, and that's the cool factor. And there's a lot more to it. On the AC side, we can do load shedding now. So if a customer is plugged into shore power, he gets to its maximum shore power, we can automatically turn loads off, like one compressor on an air conditioning, or temporarily a battery charger, or temporarily a water heater. There's a lot of data logging. We can see what the system has been doing in the last couple of years. Every circuit is a dimmer too. So in terms of how do we make this happen, this is a whole bunch of interfaces that we use. We saw this one earlier, where your dash panel switches are going to a control interface. We can use standard light switches. We have a signal interface to do tank monitoring too, so we can bring in tank monitoring. There's metering interfaces for both AC and DC. That information all comes back into the bus. And then we have the output module, and that's kind of the heart of the system. And just get back to your earlier question. So per ABYC, we have to have circuit protection in the system, even though it's basically a solid state kind of system. So what we did is we're using ATC fuses that we're putting in line with the circuit, with the MOSFET. So this is rated at 20 amps. Let's say this whole box goes dead. The digital side of it is dead. Now what you do is you take that ATC fuse out, you put it in the circuit above it, and now it becomes a conventional circuit. So we call this kind of the limp home scenario.
So it just bypasses that.
You're bypassing that circuit. So now, if you take this out, plug it in, now your light comes on, or your pump runs. So this is the redundancy part.
Yeah. And that's the overprotection. There's no other overprotection device other than that particular.
Exactly. Yeah. Yeah. Yes, sir.
Is this system going to be, or is it compatible with like a wireless system like the Octoplex is?
Well, Octomax is kind of a competitor.
Yes.
So is it compatible? No.
No, not compatible.
Oh.
Like, will it work as a wireless system?
Yes. Yeah, and I get to that in a second. Yeah. So this is kind of the bypass. Now, this is actually a full day training. So I don't want to go too far into detail, but when you program the system and tell, okay, this switch needs to control that output, that information in an Octoplex system is actually, that logic is in the main screen that they have. That screen controls every circuit. Our logic is in every box that you saw earlier. Now, if a system has, let's say, 50 boxes on it, and one goes down, what you do is you take that box out. There is a dip switch setting here, which is kind of an ID for that box. You copy that on a new one, you plug it in. The NEMA network actually recognizes that and downloads the actual configuration from a different box to the new box. And the customer is back up and running in 10 seconds. It's that simple.
If he has a spare one.
If he has a spare one, correct. So on the bigger boats that go across Atlantic, what have you, they typically have a few spare boxes.
So you can't swap boxes.
You can swap boxes, but you do have to, they all have their own personal ID. So as long as you change that ID with the dip switches, you can bring one box that you don't use and inbound the boat to, let's say, the salon, and then that will do the exact same thing with that one. So if you have a system with 50 boxes, the boat sinks, and one survived, you could replace the 49, and your system is back up and running in 10 seconds. Yep. Now this is talking about the wireless part of it. So we have currently a 10-inch screen. We have a 5-inch screen that has a built-in Wi-Fi module, just like the Garmin 7800 series and the 8000 series. And what that allows you to do is hook up an iPad, but it's still within range of the boat. We don't do it remotely yet. The next step would be is the mobile device, in this case a cell phone, what it allows you to do. So I got a couple of screenshots here to end with. So this is what you could see on an iPad or on the main screen. You have push buttons. You can do multiple pages with renderings of the boat. And as soon as you turn on, let's say, a cockpit light, you can see that here, and it will come on the actual rendering. If you then touch on it, you can see more information about what the load is, what the current is, what the voltage is at that point. Because the system speaks NMEA 2000, we can also bring in other third-party information, like oil pressure, fridge temperature. As long as that speaks NEMA 2000, we can bring that into this favorite page. You can do it for sailboats, so then we switch the switches over. So so if you change to a different rendering here, this whole page could change all of a sudden. If the second page would be a top view, and you only want to control certain circuits for that, you could change all this layout here with different switches and different information. I have customers that have 10 pages set up. So depending on where they use it, if they're at the dock, if they're fishing, if they're offline. Now here's the cool thing is that we have integration partners. So we work together with Furuno and Garmin and also with Navico products, where we have dedicated pages in their system. And that's really cool because now people really intend to have, they don't want to have 5 different control panels anymore. They want to have 1 or 2 big glass cockpit panels and control and monitor everything from there. So this is a great example of the Garmin. So what we do here on top is we have modes, and that's built into the Garmin screen. It's like almost like the Windows where you have your bar on the bottom of it. They can do it on the top and on the bottom. And the nice thing with customers like is that you can select, let's say, an all on, or you can do an all off. And that all can be set by the customer. So the customer can step on the boat, and he pushes one button, and all his preferred lights comes on at his preferred dim settings. Yeah. The sports fish market really loves it that there's a fishing mode that will turn on pumps, that will have other devices running at that point. There's a night mode that turns on automatically. Then let's see all the nav lights and will dim then all your gondola lights, for instance. So these modes are just one push, and you'll get them to the setting that you want. Yep. There's more information in it. You can actually see your current stream. So this is where you see all your AC power coming in from the dock and the generator. It runs through the system, and then you can actually see what power comes in and goes to your different loads on the boat. Inverter charger we can integrate. Favorite pages. So they have virtual calling switches now on it. They also now, by just checking one box, if a customer is more looking for, let's say, contemporary push button switch, all of a sudden it changes over to contemporary push button switches. So you can change that. You can do split screens. And this is, for instance, what you could do up in that tower. So you can control your lights, your horns, your switches, everything. And at the same time, you can use your GPS and your depth sounder at the same time.
What is all this add to the call?
That Garmin screen does not cost anything more. That firmware is standard in the Garmin screen. So that is a freebie. Yep.
The rest of it's not.
The hardware? No. Hey, but if you want features on your boat, I mean, someone's got to pay for it. So you can do analog meters. So that's about digital switching. Any more questions? Well, that's what John's going to talk about.
One of the biggest problems that I've seen is with the glass faux switches, since they're in most cases moisture sensitive to your finger, and you're in an environment that has very varying moisture levels.
Yeah.
We were on a boat where we couldn't start the damn motors.
Yeah.
We couldn't find one of us that had the proper moisture content in our fingers to get the goddamn switch to operate to start the motors.
No, I totally agree. There's some essential loads that you never want to control.
Yeah.
And so let's say a horn, wipers, start stopping of a generator or an engine. I totally agree with that. I have a few customers that do like it, like Yellowfin. They have on all their boats, and there's no switch on the dashboard. I'm not a big fan of that. Because now you have to go in your screen to the right switch to make sure that you can control the horn when you need to control the horn, right? I mean, nav lights is fine. I mean, you go through a couple of pages and then you turn the nav lights on. I mean, you only turn it on and off once a night. But, you know, something that you need to do instantly. So any reason, yes, sir? Yeah, that totally depends on the configuration and the size of the boat. We just did a 50-foot boat. The system was probably somewhere around $15,000. And then there's some engineering involved, so let's say $18,000 compared to a conventional breaker panel, $8,000. Only, so it's about twice. And that does not include the wire and cable savings. So in terms of resources, we have 6 catalogs, one for each brand. If you guys need one, let us know. You can also get it from your local distributor. There's some videos online that you can look at, also for C-Zone, some of the installation videos for Blue Sea. There is an app actually on what we call the Circuit Wizard app. Have you guys downloaded that yet from Blue Sea? It's for free. What that allows you to do is put information and parameters in, and it'll tell you exactly what circuit breaker you need and what size wire you need. It's actually really cool. So, any other questions? I already ran over.
So you're using an electronic circuit breaker?
Yes. It's called solid state. It's in the digital switching side, you mean?
How do you reset it?
It's electronic. So if that circuit trips, that's a pretty good question. So if that circuit trips, it basically opens up. It's solid state. It's not a mechanical switch. And then it will tell you on the screen, like, hey, your circuit from that and that light just tripped. Now you have to physically acknowledge that. Then you can troubleshoot it, and then you can recall, and then you can close that circuit.
And if the fault's still there?
If the fault is still there, it will instantly trip again. Yep. But the nice of it is the customers be notified that there is an issue.
What are you doing about lightning protection?
What do you do about lightning protection? Just buy a new boat. No, it's like with any conventional system. I mean, we do Viking. I mean, they got these big, these big outriggers and stuff, and they always get like a couple of lightning strikes a year. Yeah, that would take down a conventional system too. So yeah, in some cases, you have to replace some of the modules, and in some cases, it just goes straight to the grounding system and then ends up in the water. So. But that's why we have those bypasses, that at least, if that happens when you use the Bahamas, at least you can still bypass the circuit and make it conventional. Thank you, appreciate it. Well, it's on the laptop already, but you can have this.
That's good.
Sorry, I ran over. A lot of questions.